Ora nezurora izikamwa na beri na hardwood. Okay, check it out. This is Wispan of TSM Engineering for CNC titanium machining. So we're doing it here every day, every hour. CNC machining that we're operating right now is cutting some threads there. Okay, this is an engineering workshop where we do it every day. Machining is our food. Okay, thank you for watching. It's gonna go back with a rapid feed. You can come in with a cut. Okay, so this is what exactly is happening here. It's cutting, then it comes back with a rapid feed, go in, now it is finished. So it's going to change position, then it stops machining. Okay, stops the program. That's the end of the program. Okay, so if we go back to our program, we say program. So this was basically the program that I put in. There was turning cycle first, and then machining threading cycle next. Okay, so let me press Rico so that you can see. I was starting to machine my machining stock with 78. Okay, it's an 80mm diameter, but it was wrapped down to 80. Okay, to 78. So then that's my starting point on Z-axis, and then Z point, I'm starting from the zero, from the end of, or the edge of my job, and then that's the X value for my finishing size. Okay, so I was machining down to 52, and then the length of my machining stock was going to be the machined stock, it's going to be 58, so it's negative 58. So the final diameter as well is 52. So this and this are basically the same. And then on point number 1, I didn't have a chamfer, that's why I left it at I didn't want a chamfer or a radius, that's why I leave it like that. And then at point number 2, that is there, I wanted a sort of a radius so that it won't have a sharp edge, so that it doesn't break, you know. So I put a radius of 0.8, and then on the third position here, I wanted a chamfer so that I can start to cut my thread nicely. 45 degrees chamfer, so I just put it there, 2.5 chamfer. That's why if I take you down there, you will see the chamfer. Okay, so this is basically my wrapping speed was, my wrapping feed was 0.3, okay, with 250 RPMs, to number 1, offset number 1 as well, and my finishing speed was 0.18, 400 with a 2 number 1, and then the offset number 1. This is my cut size, my feed size from each side. So this is going to, it's 1.2, so times 2, which means I'm removing 2.4 millimeters on the diameter. So now if I'm at 50 minus 2.4, which means it's gonna be 77.6 when I make one cut. Okay, so this is what I want the machine to leave along x-axis on the diameter. I want it to leave something like 0.4 on each side, so it will be 0.8 in total in diameter, and then 0.1 on the face of the job. That's on my Z. So when I do my finishing, it's gonna touch 0.1 on the Z, and then touch that 0.4 and finish my cutting on the X. Okay, so, and this is my my coolant. It was on counterclockwise direction, it was outside profiling, and then we've got the gear range. It was 2. The small maximum speed that I wanted was 499. It's constant surface speed, so that I can have my surface looking all the same all the way. Okay, so this is how it is. This is a factory machine. So I'm gonna take you back to the machine so I can show you what was happening. So this is my 2 number 1. So for turning, I use that one for turning, and I put my 2 number 2, my threading 2 on 2 number 2. Then I came in, so I started machining from this diameter here, because I told you this is an 8mm stock. So I started machining in 78. So I come in here, I start cutting until I get to my final diameter, which was 52. I wanted to cut the threads, so I put a chamfer here with the turning tool, and then goes to the 2 change position, it changed to number 2, and start cutting the threads, as you will see. So this is beautiful, guys. Let me tell you something. CNC machine, something fantabulous, something fantastic that you need to learn and see every day. This is a whole story of machining come true. You know, I'm saying CNC. We've got a CNC that is manual. We've got this one and a conventional 5.2 meter bed lathe, and some whole load of machines, of milling machines, and the boring mill right down there. They are all conventional machines, and a slotting machine. I've got also another machine that I would like to show you, a CNC plasma cutter that is down there. So it's also computerized, programmed, and then you can cut any shape or any type of style you want. Okay, you can draw on a computer any zigzag shape or any regular shape. Then you come to the computer and you can do your operations and cut the material. Okay, this is for cutting plates. All right. So this is how it looks like here. So there's the cutting torch. You see there's a space that has been cut a certain shape here according to what you want. Put the plate in the, okay, there's the upper thing. Oh, the upper thing is that side. So cool, man. Keep watching on YouTube.